Hello everyone, welcome back. So in this video, we are going to understand a very important question from the Leetcode is fruit in baskets. So it is a very interesting problem. If you understand the logic, it is easy to implement it. Okay. So the question is saying that you are visiting a farm, right? What we are going to do, we are visiting a farm that has a single row of fruits trees. Means there is a row, that row contains a trees and that trees contains fruits. Okay, means fruits tree arranged from left to right. Okay, so the trees are represented by an integer array that is called fruits. Okay, so there is all these trees as represented as a fruits. Okay, means fruits is an array, integer array. Okay, where fruits at I means at index elements at index I in the fruits is a type of fruit. Okay, it's not a number of fruit, it's or not any another things, right? It's a type of fruit. Okay, let's suppose type means what? Let's represent apple as a 1, banana as 2, or guava as a 3, like that we can say that. Okay, so it contains what? The type, not the number of fruits. It's a type of fruit. Understand? The ith reproduces, so each index produces the type of fruit. Can we say that? We can say that, right? Means each tree contains or produces what? The type of fruits. I hope you understand. So this line is very important to understand what the question have we have given. Okay, now the logic stands here. You are, or you want to collect as much as possible the all the fruits. Okay, you want to collect as much as fruit as possible. Okay, means we want to collect many fruits as we want, right? But there is condition. However, the owner has some strict rule that you must follow while you are collecting the fruits, right? You need to follow the rules. What are the rules is there? There is two rules is there. You can see here. Okay, three rules is there. Okay, the very first rule is you have only two baskets. You only have what? Two baskets. Okay, so each basket can only hold a single type of fruit. Means, let's suppose you have two baskets. So one basket, or you can say all other basket, each baskets, right, can contain a single type of fruit. Either he can in one basket we can take all the fruits. Let's suppose apple will put in one basket, banana will put into another basket. Like that we can keep in the basket. So there is two baskets. Either you will store the two fruits, fruit A and fruit B, fruit 1 or fruit 2, like that we can say. Okay, there is no limit on the amount of fruit each basket can hold, right? A basket can hold as much as possible. It is very flexible. Can we say that? Means no need to worry about the capacity of the basket. Okay, now try to understand, starting from any tree of your choice, right? If you're choosing any of the starting position, that let's suppose I'll start from not 0, I want to start from 1. Okay, the index can be vary, right? So that is your choice, you from where you want to start. Okay, you must pick exactly one fruit from every tree, right? What you want to do, you want to pick what? You want to pick exactly one fruit every tree, from the every tree. Okay, let's understand how. Because this is a start tree, so you can include that start tree also from where you want to start. So you have to pick exactly one fruit from every tree. Okay, so while moving to the right direction, right, moving to the right side, you will suppose it's array, so you can start from 0 and you will go to the its length n minus 1 index. Okay, so the pick fruit must fit into one of your baskets. Means when you are picking some fruits, right, from every tree, right, you should store in the basket. Okay, so two baskets you have given, so you have to store there. So once you reach a tree with fruit that cannot fit in your basket, you must stop, right? So when you have to, this is the logic, gives you some hidden choices. Means once you reach a tree with a fruit that cannot fit in your basket, what does it mean? Think. Means the very first it was saying that, try to understand here itself, right? Very first what is saying, we have given only two baskets, right? And each basket can store only one type of fruit, either one apple or banana, right? only one type. Means if we have two basket, we can store only two type of fruits, right? Either apple or banana. You cannot store the guava, right? Like that we can say. If apple is 1, banana is 2, and guava is 3, means if this array contains 1 or 2, right, we can store in these two baskets. When we will stop, if the guava will come, we will stop here. I hope you understand, right? Let's try to understand through the example. Let's try to understand through this example. Very first, what we have given fruits. We have given 1 2 3, sorry, 1 to 1. Okay, means one. How many types of fruits we have here? Only two types. 1 and 2. 1 is coming 2 times, means let's suppose 1 is apple, so apple is coming 2 times, and banana is 2, banana is coming only 1 times, right? Means we can say the tree index at 0 and tree at index 1 contains apple tree, and it produces apple. Index 1 contains what? Is a tree that gives our banana, right? So we have only two type of fruits, so we can pick all of them because the type of both are same. Okay, so till we have only two types, so we have to take only two types of fruit each, because only two baskets we have, means two type of fruits we have to store, not the third type. Let's see in this example how many types we have here. We have three types of baskets we have, right? So let's understand. If we will pick 0 and 1, right, means type is 0 and 1, right? So there is two type of fruits we have. If we'll go to pick 3, we cannot pick 3. Why? Because this is three types of, because one type, two type, and three type, right? So three type we can store because we have to only two baskets are there, and each basket can store only one type of the fruit. So in this case, what we will do, let's suppose we'll take 0 and 1. So if we'll pick 0 and 1, means we are picking only two fruits. But if a person can start from 1 and go till the last, right, how many types of fruits is there? Two type of fruits are there, but how many fruits he can store? He can store three fruits. Three type of fruits he can how many? Three type of fruit he can pick here. Three fruit he can pick from three tree. We can say it can pick, not the tree, sorry. Okay, so we can pick the trees like this. We have given 1 2 2, and we have started the tree at the first tree, right? Means from here, and we can go here. But if we'll take 0 and 1, we will get maximum 2, right? So we have to pick from as much as tree, right? So if we'll start from here, we will get only two type of fruits, but have the maximum picking we can do that, right? But if we'll start from 0, we cannot pick that. I hope you understand, right? Similarly, if you observe this one, right, how many type of fruits we have? We have three types of fruit we have, right? 1 2 and 3. If you'll start from 1, you will get only one type of fruit. But if you start from 2 3 3 like this, we will get how many? 4 fruits we will pick. So you should understand what we need to do. Okay, let's try to go through the slides so you can understand visually. We can understand. Okay, so let's understand. If this is an array, right, that contains 1 2 1 2 and 3. So if I will represent this one as a apple, and 2 as a orange, and 3 as a banana, right? So this array contains three type of what? Fruits, right? So we don't want to do that. So can we say that either we will pick what? Apple and orange, or apple or banana, or either we can take what? Apple and orange, or orange and banana. Like the combinations can be either of the one of the two fruits from here out of the three, right? So if you understand what the question is saying, that we have given the fruits, right, and where each element represents a type of fruit in the array. Can we say that we are asking to pick the fruits from the given tree, right? Means we have to find how many trees we can pick, right, from the fruits tree, we can say. Okay, so we are walking from left to right, one tree at a time, right? So we have given only two baskets we have given, and each basket can contain only one type of fruit, right? And we can pick one fruit from each of the tree when we pass from there, right? So we must stop when we can't carry a fruit because it's a third type, right? We must stop. We have to stop there. We'll not continue if we are getting more than two type of fruits, right? If third type of fruit is coming, we have to stop. Then we can say what is our goal? Our goal is to pick the fruit from the longest continuous subarray. But we have to think about that. Our goal is to find the longest continuous array, right? And we have to return it. So question is not different. If you understand the longest continuous subarray, it is very easy to understand. Okay, so we can say this question, fruit in the basket, belongs to the concept of longest contiguous subarray. Means it's a segment of tree problem. Okay, so we'll pick the fruit from the longest contiguous subarray, and that we need to find, right? Where we have given that it contains most of at most two fruits type we have to take. If third type of fruits is coming, we have to stop it. We will break the continuous subarray. Then we'll return the maximum number of fruit we can collect. So let's try to understand through an example. Let's suppose we have given 1, 2, 1, 2, and the 3 we have, right? And we have given these two baskets. So each basket contain a single type of fruit. Let's suppose I'll put 1, means this first basket will take only one elements here, right? Another will take 2 and 2, so we'll put into another basket. I hope you understand, right? So can we say that if we walk from let's say left to right side like this direction, right? It means what will happen? Very first we need to pick first element, right? First fruit we can say, okay, here. So if we'll pick the one, right, we will put into basket 1. Can we say that? Then we are going to pick another, that is 2, right? So can we say that this is a type 2, type 1 and type 2? Okay, fine, we can put into another basket. So these both basket contain 1 and 2 respectively. Now when we are going to pick this one means we'll say okay, fine, we are good. We have to pick this one, and this is still a type 1 or 2. So the either type 1 and 2 is there, means we are talking about this type, right? Either type 1 or type 2, we are fine. It's still one type 1 and 2 only, so we can pick it. Let's pick it. Okay, we'll do for this 2 also. The third type is coming. When the third type is coming, means we are going to pick the 3. Means now how many types we have? 1, 2 and 3. If type is 1, 2 and 3, means we got the third type. Once you got the third type, you must stop here. Okay, you will not continue here. Means you got the from here 1 to 2 you will go. Okay, and you will not pick the 3 because it is coming the third type of fruit, right? Let's suppose 1 is apple, 2 is banana, and C is guava. So it means what? We will not continue to collect the guava. First we'll take apple and banana, but we'll not take for the third type of fruit. Okay, so the longest segment is 1 2 1 2. Can we say that? And what is the size of this segment? Means the subarray. We can say length is 4, and we'll return answer as a 4. We'll say okay, answer is 4, and we'll return it. Okay, I hope you understand the question and the example. What is the important note? So we are not allowed to skip any tree. We have to take the contiguous subarray, right? It means if the given array we have contiguous subarray means what? Give me 1 second. If you are new in the programming, it's okay. Let's suppose a array contains index 0, index 1, index 2, index 3. So let's suppose 1, 2, 3 and 4. So can we see that these are the elements in the array? So array is look like what? Let's call is nums. Okay, nums contains an array. There can be a size is 4. If we represent this, we can represent like this visually. Okay, so can we say that this 1, 2, 3 and 4 are the elements of nums? Yes, we can say that. So what are the index? Index is 0, 1, 2 and 3. So if we want to get the so this is called contiguous array, right? Because array contains its next what you call index, incremented order, right? After 0 we know 1 will come, after 1 it will come 2, like that we have to. If you want to traverse, if you want to find the 4, if you have to start from where, at 0, then 1, then 2, then 3. That is why it is array is called contiguous array, right? So from here we have to get the sub arrays, right? Sub array can be anything. 1, we can take 3 and 4, but this is not contiguous because we are skipping what, we are skipping 2. We cannot skip. If we are skipping that, that is not contiguous. So if we'll take, so this is not contiguous. If we'll take 1, 2 and 3, this is contiguous. Okay, so this sub array will be a valid for this one. Means if we are allowing the tree to skip, means this question will not work. Okay, this approach will not work. I hope you understand, right? So we are not allowed to skip the trees. Can we say that? Very first, then we must pick from every element, every tree in the valid segment, right? That we have seen. And we can only store 2 type of fruits. If third type is coming, we have to stop it. Let's try to understand again. Let's suppose we have given this fruit. How many type of fruits is there? We have 1, then 2, 3 and 4. 4 type of fruit is there. So we can take either 1, 2 or 3, 4 or 2, 3 or 1, 4. Can we say that? These are the possibilities that we have to take it, right? So if, let's suppose we are going to slide from here, okay, from this side, okay, we'll keep moving here. If we'll take, let's suppose I want to find the longest one. So let's suppose I'll take the from 1 to 2, this part. Can we say that how many fruits we are getting? 5 fruits we are getting, right? And if we want to take from this 2 to this 3, right, we can take it. How many fruits we have here, right? We have 5, right? 4 and 5, yeah, 5. It's also having 5. So this is also having 5, this is also having 5. But if you observe this, there is only 2 type of fruit, 1 and 2. Here is 1 and 2. If you talk about this array, it contains 1, 2 and 3, 1, 2 and 3. So this is not valid, okay, because it includes how many types of fruit? 3 types of fruit. So this subarray is not valid. So this is the basic concept to understand this problem. I hope you understand, right? You cannot skip any of these, okay, because this is continuous subarray. So if you are finding the subarray that having maximum values, but you have to also check the types. If 3 types is coming, you have to stop it. Now think of the problem as what are the longest continuous subarray? Right? Continuous segment means subarray. So if you are talking about what is the continuous segment subarray in which there are only 2 types of fruit, right? This is our intuition. So to understand the intuition, you should understand the what we have given. What are the question we have? Question is asking. So what are the continuous segment or subarray we can say that contains only 2 type of fruits, right? That previous example we have seen, right? So this is a classical sliding window approach problem. Okay, so we'll use this approach. So we are looking for the maximum length subarray with at most 2 distinct value. So we have the, if you observe the previous one, we have to find the maximum subarray. So we have got the maximum subarray, but we have to also check the types, right? And that is why we are saying here at most 2 distinct values we have to check. If it is coming more than 2, it is not valid. So as soon as we have more than 2 types, we shrink the window, right? You know the sliding window, right? From the left side, and we are back to the only 2 types. Let's suppose we have 0, example 1, 0, 1, 2, 3. Let's suppose we call 1 and 3, like this example. Okay. So if we will start from here, right, we can get from only 0 and 1, right? So your windows start from here, right, and ends at here. Okay, so if the left is at here, okay, and right will keep moving ahead. So left first it was here, left and right both are initially at the same point. So we first window is start from where, here to here. We'll say okay, left will store here, let's move the right, so right will come here. So we'll check, okay, fine. When the right will move further ahead, so right will reach here and your left is still here, right? It means in the sliding window what will happen, your window will come here to here, right? Now it is not here. Well, till here to here, your window is here to here. It means when you reach here, you find 2. Okay. First type was 0, another is 1. This is the third type. Okay. What we need to do? It means let's shrink from here, right? You will shrink from here. So you will remove the left from here and you will move left here now at this point. So your left will start from here. So you will start, okay, fine. Let's continue further. So this is the window, current window. You will move the right again here. Okay, fine. This is only one type. So type 1, type 2. Again, type 1 is coming. So fine, your window increased here. Understand? So this is a classical sliding window and you've got this maximum value. I hope you understand, right? If you have any doubt, let me know in the comment section, guys. Okay, so that is, it is saying as soon as we found more than 2 types, we have to shrink the window. From where? From the left side until we are back to only 2 types. Now try to understand what is our observation, right? So we only carry 2 types of fruit at a time, not more than 2 types. Understand? So we must pick every fruit in the current window. Okay, only we have to pick every fruits in the current window. Once the third window appears, give me a second. If once a third window appears, we have to remove the fruit from the left, right, as we have seen, until we are back to the type 2. So sliding window approach we will apply, right? So we'll use, very first is has map, where we'll take the key and value and we'll keep track of count of each fruit. So this is your, let's suppose this is fruit type 1. Fruit type 1 is coming the first time, it is 1. When the fruit type 1 is coming again, we'll increase the count as a 2. Like that, we'll keep adding on the map. We will keep updating the map. Okay. For what? In the current window itself. Now, what is the 2 pointers we'll take? We'll take the left, we'll start from the window, and right will keep moving ahead till the end of the window. So for example, let's suppose you have the left at here and you know the right is also here, right? We have to increase the right again. So when we'll take right, sorry, when your right is at 0, right at here, means we have to take what? The map, means left and right both are at the same position. It means what is the map value we have? Map value will be 1 is to 1, means 1 contains 1 time, means the count of 1 is 1. No other elements in the map. Now when we reach to 1, what we will see? Okay, means we have to move, we are moving here, means right is at here at this position, but left is at where? At here itself. So now we can say, okay, leave it for now. So we'll say now we have got what? We have to update our map. We got the type 2, right? So type 1 contains 1 count, type 2 contains count this one. Okay, it's fine, no problem. What is the size of the map? Is 2, means the type is enough for us, right? Now we'll check the further, we have to check the further element, right? So we'll check, okay, let's move to the right at here. So right will come here at this position. We found the 1 is coming. So type is between this, no problem. Type is fine, no problem. So our window keep increasing like this from here. Now it will go right will go here. Okay, type is again same, no problem. We'll keep updating. So we have updated here, then we have updated here. Okay, so now 1 is coming 2 times, 2 is coming 2 times, right? We are fine till now. Now when we reach, when the right will come here, he will see, okay, this is the third type is coming. Okay, so when till here it is coming, fine, no problem. When it is to here, it means it will show, okay, it is coming type 3, right? So type 3 is coming. What we need to do? We'll say we have to discard it. Okay, but still we'll keep updating our window. Let's suppose for this one, so we will see, okay, this is type 3 is coming, means 3 we have here. So when the left was at 0, we'll keep moving from here 0 to it will keep left at 0 itself when the window was from here to here, right? And right, we were moving from here to here, right? We have seen, correct? And we found the window. So this was the window we have seen. As you can see, what is the largest window? So when we update 3 at here, right, so window will stay 2 to 3 itself. The left will come here, let's suppose, and right is here. So your small window is hit here. So another window will say, okay, 2 3. What is the longest one? So longest one is this one. But if the max length we're talking about, so max length will keep updating at each time, right? But the max length is the global value. If the another window is coming, it we have to take the max. So we'll say okay, fine. It is, we have the window, but we have the max is 4 because we got the max at here is 4. Okay. So programmatically we have to think. Okay. Very first, what you need to do, you will create the map, right? This map is your basket. Can we say that? And left is 0 and max length will take 0. Okay. So max length is nothing but max peak, we can say that. Okay. And we'll start the right at 0. We'll keep moving ahead, right? And then we will check the map, right? So very first we'll check, once we will check the map, right? What we need to do, we'll say okay, add this fruit value, and this is the current value on the map, right? Very first when 1 is coming, so what we done, 1 1 we have added, right? 1 is coming again means we have to update 2. So first we will get from the map, right? If it is very first it came, right, the one we are going to add here 1, and we will check 1 is there or not. So it is saying no, we will return 0, and we'll say 0, and we'll do +1, we'll update to 1, right? When the next time 1 is coming, so we'll do the map dot get default. So we'll pass this value, it will give you some value, right? Let's suppose 1, it was 1 there, so we will say okay, next time it is coming, just add 1 more. We'll keep updating it. Okay, I hope you understand. So this time it will become 1 is to 2, like this. The map will contain like this. Okay, each entry of the value. So like that we will keep moving ahead until the map contains size is greater than 2. We have to do what? We'll remove the its count from the map. Okay, if it is less than 2, it's fine. Less than equal to this, then fine. Okay, then we'll check if map contains left, right, equal to 0, right? What we need to do, we'll remove from the here. Okay, and then we'll keep checking further left plus plus, because we have to update our window. And then we need to find the max length. How we are going to find the max length? Right minus left plus 1 you will do, you will get the window. Means you know, right, where is the right is at a certain position, left is certain position, you will do the minus. So this is the positive value, let's suppose at 4, and this is at 3. 8 minus 3 will get what, 5, just for example, and we'll plus 1, we'll get the current window, because it is inclusive, start is inclusive, and you will return the max length. I hope you understand. If you have any doubt, let me know in the comment section, guys. So let's understand how we'll do that. So let's understand the fruit is we have given is 1 2 1 2 and 3. This was given, right, as we have seen. So if this is the array we have given as a fruits, okay, so very first left is 0, max length is 0, right? So map is also nothing, it is just a blank like this. Okay, all are 0. When the right, we have to loop over, right is at 0, then we'll find the what, fruits at right is what, 1, we'll get the 1, right? So we'll say 1. Now what we need to do, we will map on the map. So this map will store like the value, very first element is 1 is to 1 at this position, I'm talking about. Okay, because the element we have added is 1, we are talking about this one, so we will say like this. Okay, next we will check the size. Size is what? Size is less than equal to 2. If current size of this map is what, 1, and it is less than equal to 2, it means this is valid. We'll say okay, this is valid, so it will not go in this loop. I hope you understand. This will not go in the loop. Where it will come? It will come here. So you will update the max. So we'll say okay, what is the max now? Max length is nothing but this is 0 initially, this is 0 minus 0 plus 1. So we'll say 1, right? What is maximum? 0 and 1. What is maximum? 1. So we'll say update 1. Okay, so current window, we'll say max length is this is the current window length, that is 1. Like this we have to keep updating until you will find till here, right? You will find the max length 4, as we have seen in the diagram, right? So once you will reach here, right, here you will see the third element is coming, this one. So once this 3 is coming, means this loop will, we will find the loop is max size is coming greater than equal to 2, right? Because it was some value was there, means 1 is to 2 was there, then we have seen how many, 2, 2 is also 2, is also 2. When 3 is coming, we'll add the 3 is to 1, like this, right? So what is the max size is there, current size is 3, and it is not valid. If it is not valid, means we'll go into this while loop. Once this while loop will we will update, right? So first of all, what you need to do, map dot get fruit size at left. So you will return, you will do what is at left, left is at where, at here itself. Till now we have left at here, right? So we'll remove the left at here, okay, and we'll say okay, continue here till here. So you will remove the -1, you will do, right? What is that, what is at left, left is at a 1 is to 2. So now 1 is to 1 will happen, right? So we'll remove this one. Now what we will do, you will check if map dot get, right? If you'll do map dot get, you will get some value, right? If it is equal to 0, let's suppose, means we have to remove until the size is greater than 2. You have to keep removing that, okay? And once you remove that, you will say okay, size is, the fruit length had, this one is coming 0, right? The very first it was 2, you have removed -1, you have done, right? So you will got 1 is to 1, you will take 1 is to 0 now, right? So it is, when is 0, it is 0, means just now remove from here. I hope you understand, right? And then you will do left plus plus. So your left will keep moving ahead, right? Once you keep moving ahead, right, you will get the this value. So let's suppose this is your 4. Then this is right is at certain position. Let's suppose what is the right is there? 0, 1, 2, 3, 4. So right is at 4. Let's suppose left is at certain position. Can we say that is at very, it was 0, then 1 and 2. Let's suppose it was at 2, and we'll do +1. So still you are getting the 4 max value, right? So we'll return 4 as a max value. Okay guys, as we have seen guys in the example we have seen the here, I'll show you the where we have shown the diagram. Yeah, this one I'm talking about here, right? So we have seen this, how the map contains the value.